Now I'm going to show you how to simplify rational expressions, and people always get a little nervous with these things because they look so ugly, but they're really not that bad. And what we mean by simplify rational expressions is the same thing I would mean if I said, hey, this is a dumb way of writing another number, right? Who would write 8/4? You would write 2. And so what you did here is you actually recognized, hey, this is 2 times 4 over 4. So I can cancel out the 4's out of everything and get 2 over 1, which is 2. And so we'll use those same techniques, the techniques you would use for typical fractions in here. So for example, this first one, we factor everything we can. That's the difference of squares in the numerators. That's x minus 4 times x plus 4. And the denominator, I'm looking for two things to multiply to give me negative 8 and add to give me negative 2. So that's going to be x minus 4 and x plus 2. Now that I have a product or a factor of x minus 4 in the numerator and the denominator, I'm allowed to cancel those out. And the reason is because x minus 4 over x minus 4 is the same as saying 1. And 1 times something doesn't change anything. So here my solution is x plus 4 over x plus 2. If you cancel out these x's, your teacher is just going to throw up in a trash can. Do not cancel these x's out. Alright, now let's move on to B part. It's a similar situation. This time we have divides. So what I want to do here is I want to factor everything I can. So firstly, two things to multiply to give me 9, negative 9, add to give me negative 8. That's going to be negative 9 and positive 1. And the denominator, I can take out the 3. So let's think for a moment. If I took out that 3, this 243 wouldn't be 243, it would be 81, because 81 times 3 is 243. So now that's 3 times x squared minus 81, that's the difference of squares. That's going to be x minus 9 times x plus 9. Okay, now division, well, let's leave this alone for a minute. We'll get to the division part in a second. Let's just factor the second part here. So in the numerator, two things that multiply to give me 9, add to give me 10. How about x plus 1 and x plus 9? In the denominator, two things that add to give me, multiply to give me 81 and add to give me 18. I think that's going to be 9 and 9. Alright, so here we have it. Everything's factored. And I want to cancel out some stuff. But I have to remember here that anytime you divide by a fraction, that's the same as multiplying by its reciprocal. So here I have x plus 9 times x minus 9 times x plus 1 over 3 times x minus 9 x plus 9 times the reciprocal of this guy. So that means the denominator is now my numerator. I just flipped it upside down. And now I'm free to cancel. So let's think. X minus 9 and x minus 9 cancel. X plus 1, x plus 1 cancel. X plus 9, x plus 9 cancel. And actually everything canceled except in the numerator I had a 1 and the denominator I just had that 3. So this whole thing was actually just 1/3. So you can see why this is useful to do. Alright, let's look at a couple more examples. So in part C, I'm trying to add these two things. And what I always teach is think about if I'm trying to add 1/4 and 1/3. How do I do that? I have to get a common denominator. And so in this case, what I would do is I'd say, let's multiply a 3 over 3, because 3 over 3 is 1. Doesn't change anything, just change the format. That gives me 3/12. And on this side, I can multiply by 4 over 4. And so that gives me 4/12. Now that they have the common denominator, they're in the same type, I can add them together. So I get 7/12. Okay, so I need to do, for part C, I need to do a similar thing. What my common denominator here is going to be x plus 1 times x minus 1. I already know that. So I'm going to go ahead and put that in on both of these. Now the question is how do I get from this to that denominator? Just like over here, I had to multiply the missing piece, the 3 over 3. Here I need to multiply in x minus 1 times x minus 1. So that's going to give me x times x minus 1 in that numerator. On the other side, I'm missing the x plus 1 for my common denominator. So I need to multiply in x plus 1 over x plus 1. So now I have 2x minus 5. Please put parentheses around that so you remember that all of this is being multiplied by all of this. Okay, like that. Okay, from there, I can bring them together to have a common denominator of x plus 1 times x minus 1. And all I have to do is clean up the numerator. So here I distribute across, I get x squared minus x. Here I FOIL, and so I'd get, let's see, 2x squared plus 2x minus 5x minus 5. And so cleaning this up now, I have 3x squared. How many x's do I have? A minus, let's see, you have a minus 1, a plus 2, so, and that's a plus 1 in total, minus 5, so you get minus 4x minus 5 all over x plus 1, x minus 1. There you have it. You brought them together. Okay, for part D, this looks really complicated, right? Because we have fractions within fractions. But the same idea applies. All you're trying to do is get these together. You need to get the numerator to have a common denominator and the denominator have a common denominator. So what that means is I can tell that my numerator is going to have a common denominator of wx, and actually in this case the denominator will as well. So how do I get wx for all these things? For the 2 over w, I need to multiply an x over x. For the 3 over x, I need to multiply a w over w. So my new numerator has a 2x over wx plus 3w over wx. And the denominator, we do the same thing. I multiply x over x and w over w. So then I have a 3x over wx minus a 2w over wx. Now that I've done this, I'm allowed to bring together, I have 2x plus 3w over wx divided by a 3x minus 2w over wx. Okay, so this is a fraction divided by a fraction. We already said dividing by a fraction is the same as multiplying by its reciprocal. So this is the same as 2x plus 3w over wx times wx over 3x, that's a minus 2w. And now I can see the wx's will cancel out, and I'm left with 2x plus 3w over 3x minus 2w. And there it is. Alright, I know that these things can be a little complicated, but they work just like fractions you've dealt with since 3rd grade. If you have any questions, please let me know. I'd be glad to help. And I appreciate you watching. Hopefully this was helpful.